Hi class, tonight we're going to be looking at Term 3 review. This is the worksheet that you got today in class. This is over day 3. There's about 30 problems. We're going to go through those as quickly as possible here. Hopefully to help you study tonight. Alright, question number 1. Which of the following letters shown has at least one line of symmetry? We kind of did this one in class, but the correct answer here would be D. Any of the other letters we could not cut just one time in half. Alright, number 2, which polygon shown has only one line of symmetry? The correct answer here is our inverted trapezoid. All of the other polygons would have multiple lines of symmetry. Tomorrow on your term assessment, make sure to notice if they're regular polygons or not. That will help you in aiding whether or not they have one line or multiple lines of symmetry. Number 3, name the coordinates of B if a rotation of 90 degrees takes place. Well, first find my coordinates of B. I count over 1, 2, 3, 4. Count up 1, 2. So after the rotation, B prime, or my image of B, is going to change to 2, 4. And because it's a 90 degree rotation, the first coordinate is going to go opposite. So negative 2, 4. Alright, number 4. We have a reflection across the y-axis. So first find the coordinates of B again. Coordinates of B, count over 1, 2, so negative 2. Count up 1. Since it's across the y-axis, the x is only going to change, so it's positive 2, comma 1. So that's my answer for 4. Number 5, a dilation with a scale factor of 2/7 is a reduction. The key on this is my scale factor is k. If k is greater than 1, we have an enlargement. If k is less than 1, reduction. Alright, the next problem, problem number 6. We looked at this one in class, but to solve this, set up a proportion. So my proportion is x over 14 equals, I now have to incorporate this whole side, which is x plus 52. So I have x plus 52 over 30. To solve, cross multiply, 30 times x is 30x, equals 14 times x, which is 14x, plus 14 times 52, we have to distribute there, which is 728. Subtract 14x from both sides. So I'll have 16x equals 728. Divide both sides by 16. So x equals 45.5. On to problem 7. On problem 7, it wants to know which postulate or theorem lets me know that these triangles are similar. The postulate and theorem that I want to look at, first I need to find this missing angle, which we'll call it x. So 71 plus 35 plus x equals 180. Combine like terms, 71 and 35 will give me 106. Plus x equals 180, subtract 106. So x equals 74. Now that this angle is 74, we also know this angle is 74, so how are they similar? Similar by angle, angle. On to the next page, we're looking at number 8. Number 8 should be very simple. It's a similar triangle. One of my triangles is here. The other triangle is the big triangle, finding out the pine tree height. So I have 5.2 over 2.6 equals, well, I don't know the height of the tree, that's x, over the length of the shadow of the tree is 13. Cross multiply, 2.6x equals 13 times 5.2, which is going to give me 6. So 2.6x equals 67.6. When you divide by 2.6, x is going to equal 26 feet. Alright, so that was number 8. Number 9. Again, determine whether the triangles here are similar. To do that, find this missing angle. So I have 69 plus 31 plus x equals 180. Combine like terms, 69 plus 31 will give me 100, plus x equals 180, subtract 100, so x equals 80, so now this angle in here is 80, so how are they similar? Similar by angle, angle. If all three angles were not congruent here, they would not be similar, right? So if all three angles were not congruent, they would not be similar. All right, now to look at number 10. On number 10, just look at what is set up for my proportion. So I have SU, which is the whole side, over ST. I then have SQ. Well, what's that going to be over? Well, ST is right here. What matches to ST? SR. So number 10 is SR. Number 11, when looking at this, all right, you have to find that this is a 45, 45, 90 right triangle. So a 45, 45, 90 right triangle. To find the hypotenuse, I take the side and multiply by the square root of 2. So take the side, multiply by the square root of 2. So that's the answer to number 11. On number 12, all right, this is a 30, 60, 90 right triangle. I have the short side. To go from the short side to x, which is the long side, I'll take 12 times the square root of 3. To go to the short side to find the hypotenuse, I'll take 12 times 2, which will give me 24. So there's my answer on number 12. Moving forward. Number 13 here, that wonderful slide problem that all of you love so much. The opposite is what I'm looking for. This is x, that's my opposite. I have the hypotenuse. So using my trig, my SOHCAHTOA, I'm going to use sine. So the sine of 42 will equal the opposite, which is x, over 15. To solve, multiply both sides by 15. When something is in the denominator here, we have to multiply to get rid of it. So here we have x equals 15 times the sine of 42. So in this case, x is going to equal 10.04 feet. Alright? If you rounded to 10, that would be okay, but try to keep it 10.04. Number 14. Alright, another trig problem here we have. Again, stick with the SOHCAHTOA. We've got to figure out which one to use. Well, I'm looking for x. X is my opposite here. So the building is the opposite. I have the adjacent, so I'm going to use tangent. The tangent of 82.9 equals x over 102. Again, to get this by itself, I need to multiply both sides by 102. So x equals 102 times the tangent of 82.9. So on problem number 14, x will equal 819 feet. Again, it says round to the nearest foot, so that's why I'm going to make it 819. So that was on number 14. On problem 15. 15 should be very, very simple. Again, it's just finding your trig ratio. So I want the cosine of d, so I want the adjacent over the hypotenuse. So here the cosine of d will equal adjacent, which is e, over the hypotenuse, which is f. Finished. 16 wants the tangent of a. So for a, there's the adjacent, there's the opposite. So tangent TOA again, opposite over adjacent. So tangent of a equals 12 over 5. In this case, I can't simplify, so it will stay exactly like it is. Alright, number 17. On number 17, it's a two-step problem. Alright, it's a two-step problem here. First, I'm just going to act like n is invisible, like n is not even there. So here I want to find n, there's my opposite, there's the adjacent, so again I'm going to use tangent. So tangent of 41 equals m over 18. To get n by itself, multiply by 18. So m equals 18 times the tangent of 41. So here m is going to equal 15.7. Now I'm going to act like m is not there, and I'm going to find n. Well, n is the hypotenuse. So I have adjacent hypotenuse, so I'm going to use the cosine of 41 equals the adjacent, which is 18, over the hypotenuse, which is n. One trick we have for using our trig functions here is cosine of 41 and n can kind of exchange spots. I can substitute them in for each other, so n equals 18 divided by the cosine of 41. So here when I go to solve, n is going to equal 23.9. So there's my m and my n for problem 17. Alright, on to problem 18. 18, we're going to use the Pythagorean theorem. I have a triangle, I have 1, 2, my third missing side is x, so the hypotenuse. So the hypotenuse is my c squared, so a squared plus b squared equals c squared. 7 squared plus 24 squared equals x squared. 7 squared is 49. 24 squared is 576, which equals x squared. When I add these two together, I get 625 equals x squared. To solve, take the square root, so x equals 25 feet. So 18 is Pythagorean theorem. Again, 19, Pythagorean theorem again. Cover up this triangle right here. You're only dealing with one triangle. Just put an x right here, cover up the rest. Again, my right angle is here in the corner, so the hypotenuse is x. So 25 squared plus 11 squared equals x squared. 25 squared is 625, plus 11 squared is 121, equals x squared. Here, combine like terms, I get 746 when I add these together, equals x squared. To solve, take the square root of both sides, so x will equal 27.3. Okay, so there's 19. Alright, number 20. So number 20 here, what is the value of x to the nearest hundredth? Again, SOHCAHTOA, opposite, hypotenuse, I'm going to use sine of 41 equals x over 10. To solve, multiply both sides by 10. So x will equal 10 times the sine of 41. So here x equals 6.6. So that was number 20. To the back side, number 21. So figure has rotational symmetry. I got to figure out to what order. Well, there's one side, two sides, three sides, 4, 5, 6, 7, 8. So I have 360 divided by the order of symmetry, which is 8. 360 divided by 8 is going to give me 45. So the degree of rotation is 45 degrees. Alright. Number 22 here, reflecting 1 over the y-axis. So here's the y-axis, so 1 is going to go to 4. Alright. And then reflecting it again over the x-axis is going to put the figure here at figure 3. That's for 22. Number 23 now, I'm dealing with similar triangles. So set up a proportion. Whenever working with similarities, you can set up a proportion. 9 over 12 equals 27 over y. Cross multiply, 9y equals 27 times 12, which is going to give me 4. So 9y is going to equal 424, divide both sides by 9. So y is going to equal, on this problem, 36. Sorry, this should not be 424. I have made a mistake there. This should be 324. Okay, so 54 plus 270 will give me 324. So then I need to divide 9 and I get y equals 36. So that was on number 23. Number 24, find the geometric mean. 7 over x equals x over 35. Cross multiply, I get x squared equals 315. Take the square root of both sides, so x is going to equal 15.7. Sorry, this should not be 315. 7 times 5 is 35. 7 times 3 is 21, so it should be 245. My apologies. Alright, number 25, solve for the measure of angle theta. So here angle theta is going to equal, there's my opposite adjacent, so I need to use tangent. So tangent of theta equals 9 over 15. Remember, this is where you want to hit the tangent or the inverse, the second, the shift button on your calculator. So here my angle theta is going to equal tangent -1, which is 9 over 15. So the measure of angle theta will be 30.96 degrees. If you rounded to 31, that would be okay. So 30.96 degrees there for theta. So that was 25. 26, find the value of x. Again, set up a proportions, pretty much set up for us. 15 over x equals 27 over 24. Cross multiply, I get 27x equals equals 360. To solve for x, divide by 27. So x will equal 13.3. So that's for number 26. For number 27, solve for x. Again, Pythagorean theorem. So there's my x. So I have c squared, which is the hypotenuse, which is 38. So x squared plus 33 squared equals 38 squared. Alright? So now what you have to do is you have to square both of those numbers. First for 33 squared, that's going to be 1089. So x squared plus 1089 equals 38 squared, which is 1444. Subtract 1089. So x squared is going to equal 355. To solve, take the square root of both sides, so x equals 18.8. Right, the next problem, here's my opposite. Adjacent, so to solve, tangent 59 equals h over 30. Multiply both sides by 30. So h equals 30 times the tangent of 59. To solve, multiply all that out. So here h is going to equal 49.9 feet. If you rounded to 50 feet, that would be alright. Alright, our last problem here. Problem 30, find the geometric mean of the two numbers again. So we have 11 over x equals x over 21. Cross multiply, I get x squared equals 231. To solve, take the square root of both, so x equals the square root of 231, which is 15.2. Alright? If you have any more questions on any of this information and you maybe can't make it in to see me in the morning, because I know some of you can't, please send me an email. You can email me at climestone@k12.il.us. If you click on the link that says email, you can also send me an email straight from the school website. Alright, I hope this video was very helpful for some of you. If you have any questions, please come see me in the morning. Have a good evening. Good luck on your term assessments.